The first law of thermodynamics is the conservation of energy principle stated for a system where heat and work are the methods of transferring energy for a system in thermal equilibrium. Heat engines, such as this one, are a good example of this. Heat transfer into them takes place so that they can do work. Q in the first law of thermodynamics represents the net heat transfer. It is the sum of all heat transfers into and out of the system. Q is positive for net heat transfer into the system, and W is the total work done on and by the system. W is positive when more work is done by the system than on it. The change in the internal energy of the system, delta U, is related to work and heat by the first law of thermodynamics. Let's consider a thermodynamic process where a system moves from state A to state B. It is supplied with 400 joules of heat and does 100 joules of work. A asks for what the system's change in internal energy is. The first law of thermodynamics relates the internal energy change, work done by the system, and the heat transferred to the system in a simple equation. The internal energy is a function of state and is therefore fixed at any given point regardless of how the system reaches the state. So for the first law, we have the change in internal energy from state A and B equaling to the heat from A to B minus the work from A to B, equaling the 400 joules minus the 100 joules, equaling the change in internal energy being 300 joules. If the system moves from state B to A, what is its change in internal energy? So here I have an equation of the change in internal energy net equaling the change in internal energy from state A to B plus the change in internal energy from B to A equaling 0. Then consequently I have the change in internal energy from A to B equaling the negative of internal energy from B to A. Therefore, that would mean that the change in internal energy, B to A, would consequently equal the negative 300 joules that we found for the system's change in internal energy.